Hey guys, this is 2.4.1 homework. This is the first modal logic one that we've got. And looking at my formula over here, you see that it's changed a little bit. The top left ones over here, and I've got these little comma i's. Really, that's the only thing that's different between from all of them. The comma I is the world that you're at. So if I say if A then B, then I say at world I, then either it's the case that A is false at world I or B is true at world I. And that's not really a problem until we get to these guys down here. These are our new modal formulae, and you'll see boxes and diamonds. The box means necessarily, the diamonds means possibly. So not necessarily A in world I means possibly not A in world I. So that's something like, it's not necessarily true that dogs have hair in the world we're in, world 0, we'll say, then it's possibly the case that a dog does not have hair in that world, world 0, right? And then if over here, if it's not true, if it's not possible that A in world I, then necessarily it's the case that A is false in world I. So if it's not possible that I don't know, if it's not possible that circles are squares in world 0, then it's necessarily the case that circles are not squares in world 0. And our world is, or the first world will always be world 0. So, and that's just, you're just labeling. It doesn't really matter. I mean, doesn't matter, I should say, that we start off with world 0. That's just what we do. And then down here, the necessarily and the possibly. Now notice these not necessarily, not possibly, all they do is get you into the possibly and necessarily down to these forms right here. And once you get to these forms, you can get rid of the box in the diamond. But now the box you can only get rid of if you've got your world related to some world. So here it says necessarily A in world I, and I is related to a world J, then A is true in that world J, right? So if it's necessarily true that squares have 4 sides in world 0, and world 0 is related to some world, world 1, then squares have 4 sides in world 1. That's what that says. And here it says possibly A is true in I, then make I related to some other world J, and say that A is true in that world J, where J is a new world, right? So one that you haven't mentioned before. So if it's possibly the case that that cats have kittens in world 0, then say that 0 is related to some new world 1 that I haven't mentioned before. 0 is related to 1, and cats have kittens in that world, world 1. Alright, so that's all that's saying is, like, in order to say something is possibly true, then it must be true in some world. Maybe that world 1 is actually our world, maybe not, right? So yeah, I guess that's pretty much the best explanation I have for that. And tomorrow, if you need to, we can go over it some more, and I can explain it a little bit better maybe if you didn't get it this time. Let's do number 1. Number 1 says it's necessarily the case that P and Q, P and Q, I need a new stylus. I don't know how I'm surviving with this one. Necessarily P and Q in world 0. Remember, we're going to start with world 0, and then we're going to say not necessarily true that P in world 0, right? We're negating the conclusion. Now, how are we going to handle this? Well, first thing I want to do is get rid of my not necessarily, or my not possibly, and I'm going to change that into a possibly the case that not P in world 0. So if it's not necessarily the case that P in world 0, then possibly it's the case that P is false in world 0. That's what that means. And I will check this one. And then I have a box and a diamond. I look over here at my box, and I have to have it related to some world. And 0 is not related to any world just yet. I haven't said 0 related to 1 or 0 related to 2. So I can't use this rule just yet. So in fact, I'm going to have to start with the diamond rule, with this rule right here. And what that's going to do is that's going to generate some new world. If I say possibly it's the case that not P in 0, that must mean that my world 0 is related to some world in which not P is true, or in other words, P is false. So now I have this 0 related to 1. I have my world related to some new world, world 1. and I can say this world right here, 0, I say necessarily P and Q. That means in my new world, world 1, P and Q must be true. So I'll write that down here. P and Q is true in world 1. Oh, and I should not have done that. You do not check the boxes. And the reason you don't check the boxes is because you could actually have later on in this, not in this problem, but in some other problems, you could have world 0 related to world 2 as well. And that would mean, and remember, saying necessarily true means every world that you're related to, this P and Q is true in. So if 0 is also related to world 2, then I would say P and Q is true in world 2. So you don't check the boxes because you might have to apply them more than once. So now the only thing I have is P and Q is true in 1, so I'll write P1, Q1, and that's just this rule right here, the AND rule, right? Check. And now I look up, I start at the bottom, I look up the top, Q does not contradict anything, P contradicts not P in world 1, so this is valid. Valid. Alright, that was number 1. Number 2 looks like this. Possibly the case that P or Q in world 0, and then it says what? Possibly P, so I want to say not possibly P in world 0. So can I have the conclusion be true and the premise be true and the conclusion be false? I see I have a diamond and a not diamond. I want to get rid of that knots first, so I'm going to apply this rule right here. And not possibly P equals necessarily not P in world 0. Check. Possibly P or Q in world 0. I can use this diamond rule right here, and I can generate a new world. So 0 is related to 1. World 0 is related to world 1, and in world 1, P or Q is true. Check. And now I have my box right here. I have 0 is related to 1, so I'm going to say not P is true in 1. And I'm not going to check that box, right? But even though 0 is not going to be able to be related to any other world here. So I have P or Q in 1. I'm going to apply, in other words, this rule right here, this formula right here. I'm going to apply my OR rule. It's going to split these out. I'm going to say P is true in 1, Q is true in 1. Check. And then I see, starting down here, I have a contradiction right here. But starting over here, Q doesn't contradict anything, not P doesn't contradict anything. This is invalid. Now, what do we do with the counter model here? So this is invalid. I'll change the color so you can see my counter model. Invalid. And now here's what I want to say. First, I want to say all the worlds that are in my set, and that would be world 0 and world 1, right? Those are all the worlds that are in that set. And then my world 0 is related to my world 1 in that set, and I'm going to say the truth value in world 1 of P is 0 because P is false in world 1, and the truth value in world 1 of Q is 1 because Q is true in world 1. Notice I have nothing in world 0 here, right? I don't have any P's or Q's in world 0, so I don't worry about putting anything, any truth value of P in world 0. I don't know what P is in world 0. All this is saying, this counter model is saying, is when world 0 is related to some world 1, and P is false in that world and Q is true in that world, it is the case that you could have possibly P or Q and yet have the opposite of the conclusion, not possibly P in that world 0. That is all that's going on there. Let me do number 3, and then I think maybe we'll take a break and we'll do the next 2 in a different video. So number 3 starts off like so. Possibly not Q, right? Possibly, oh man, possibly not Q in world 0, and then it says not Q, so I'm going to say not Q in world 0, right? Can I have the opposite of the conclusion? Not Q is really easy. It's the not rule, right? So I'll turn that into Q0. Check. I have my diamond rule next, and the diamond rule is down here. If possibly A and 0, then 0 is related to 1, and A and 1. So 0 is related to 1, and A is not Q, right? So not Q in 1. And I'm going to check that. Now notice I have Q is false in world 1, but Q is true in world 0. That's not a contradiction, right? You can be true in one world and false in the other world. And that's pretty much the whole point of saying, of doing modal logic, right? Is to be able to say that something is true in this world, but it didn't have to be true, right? So I'm going to say this is invalid. And my worlds that I've generated, I have my set of worlds right here, world 0 and world 1. Oh, I can't do those brackets. World 0 and world 1. And then world 0 is related to world 1. And my truth value in world 0 of Q is 1. That should be an equals. Let me make that better so you're not confused. Equals 1. And my truth value in world 1 of Q equals 0. And that is because, oh shoot, yeah, that's right. That's because Q is false in world 1, right? So I said the truth value is 0 in world 1. And Q is true in world 0, so I said the truth value in world 0 of Q is 1. Alright, that was number 3. Right, okay, so let's take a break. I'll do my next video. I'll do the next two.